Hello everyone. We're finally ready to talk about 3D matrix transformations officially. So we've done plenty with 2D matrix transformations, and we saw homogeneous coordinates for doing translations. And that required a 3 by 3 matrix, right? But now we're actually going to look at 3 by 3 matrices in their own right, acting on 3D shapes. So the definition of multiplication is exactly like what you've already seen. But now you've got 3 rows and 3 columns. And we input a vector x, y, z. And the x component that we get out is the dot product of the first row with x, y, z. The y component we get out is the dot product of the second row with x, y, z. And the z component we get out is the dot product of the third row with x, y, z. And that's all there is to it. But now we can start to do some stuff to 3D shapes. So for example, if we take the matrix 2, 0, 0, 0, 1, 0, 0, 0, 1, we see what this does is this scales us 2 in the x direction. So here I'm showing my x-axis, my y-axis, and my z-axis. And you can see what that does to a cube that I start with is it stretches it out across the x direction. So now it's 2 times wider in x than it is in y or z. You can also do flips. And here's an example where I flip the x-coordinate and the z-coordinate. So I start with this cube, flip the x-coordinate, so put that on the other side here, but then also flip the z-coordinate, so then I put it below there. You can do shears too. Here's a shear that's a little bit like a shear we already saw, because I'm only messing with the x and the y. So I end up getting x plus y, y, and z. But you can also shear across multiple axes. So you don't just have to shear within the xy plane. You can also get some z action going on. You can even, you can do some pretty crazy stuff. Now this is actually easier to show what's really happening if I go to my interactive viewer. So I spent a lot of time working on, so this is, you started off before doing this sort of thing. But now if you go to this widget, so remember how to get here. You go to the schedule and then you click on Prof. Traylor's Matrix Transformation Demo widget. It's linked from last Wednesday, but now I've updated it. So if you click the 3D box, now you can do stuff in 3D. So let's just first see. Let's go back and do something simple. The first example I started with. So I put a 2 in here. See, that stretches me along x. So actually now here I'm drawing, this is more the coordinate system we'll be using in this section of the course, but notice how, so x is actually this red axis here, y is this green axis. So x and y are kind of like we were looking at them already in 2D, so x is to the right, y is up. And if we're going to keep a right-handed coordinate system, then z has to be coming towards us. So z is the blue axis here. Okay, so when I have the matrix 2, 0, 0, 0, 1, 0, 0, 0, 1, that stretches me by a factor of 2 in x. Let's see what happens when I flip the y. So I'll just make that a -1 there. Okay, so that's flipping across the y coordinate. And again, I can flip also the z coordinate. So there I flip to the other side of z and y. So I can move over with w. You can move around with w, a, s, and d, and you can rotate with your click to examine this from different points of view. But anyway, you see I flipped the z across there in addition to flipping the y down. Okay, but let's look at some of these shears because they're kind of crazy. So I'll go back just to the identity for a second. So here's our, we start with the identity matrix for 3D, which is 1, 0, 0, 0, 1, 0, 0, 0, 1. That doesn't change anything. But let's say, okay, I'll make my new x component shear based on y and z at the same time. So notice what happened. Y and z stayed the same, but my x component actually shears it in this weird diagonal way. So let me show it again. And like I was saying, you can also do a shear like this, where you shear across multiple axes. Whoops, I need a 0 there. You shear across multiple axes at once. What's interesting about the shears, though, is they preserve volume as long as you don't. So if you stick to the upper triangular part here, it doesn't matter how far you shear, you'll preserve the volume. So this looks a little crazy. So anyway, you should play around with this until you get comfortable. But it really is just a direct extension of what we've already done in 2D. Of course, the one last thing I want to mention is we also have homogeneous coordinates, just like we did for 2D. If we want to translate, we now have to go up to the 4th dimension. So we'll actually be, you can think of it as shearing a 4-dimensional cone. Or you can also just look at the algebra and see that if I go to a 4x4 matrix, and then I just take, let's say I have a vector x, if I just add a 1 and make it a 4-dimensional vector instead of a 3-dimensional vector, so I have x, y, z, and 1, then what I'll see is the result of doing this 4x4 multiplication. So where I take the dot product of the first row with this x, y, z, and 1, dot product of the second row, etc., etc. Then the result of that is multiplying the vector by the upper left 3x3 matrix, and then adding this translation vector. So that's how we can get a translation to happen for 3D vectors. So we just have to go up to 4D matrix. So here we go. Here's my 4x4 matrix. And, you know, let's say I want to move this over by 1 in x, but I can also move it up by 1 in y. And let me move it really much closer to me. Okay, so in z, I'm coming towards me. Okay, see that? So I move this over by 1 in x, up by 1 in y, and then towards me in z. So look at how far that moved in z. And, you know, I can do other things too. I can flip it and then move it, right? It's still going to do this upper 3x3 part. So that actually flipped it and then moved it. And just to remind you, you know, compositions work like they always do. So, you know, if I do A first, let's say I do the shear, I can do that, and then I can move it towards me. So this is moving it towards me by itself. That's just doing the shear. But I can do the shear and then move it towards me, right? So that's compositions work just as they have, and I can pre-multiply, so I can do them both at the same time. So anyway, I'm just showing you that everything is all the same, but look how cool this is. Now we're able to do stuff in 3D. Okay, so I'm just going to have you do a little exercise, making sure that that is clear. Rotations are a little more complicated, so we'll do that next.